This is a continuation of homework set 39. We'll look at questions 8, 9, and 10. Question 8 looks like we've got two parts, so let's read through it. It says this: how long will it take $2,000 to double if it is invested at 12% annual interest compounded 6 times a year? Enter in exact calculations around to 3 decimal places. All right, so what we're going to do is we're going to invest $2,000 at 12% compounded 6 times a year. How long is it going to take to double? So let's start with the compound interest formula. It goes like this. A, the amount of money that you've accumulated after so many years, is equal to this. P, that's the principal, that's the amount that you invest, times this quantity. 1 plus R over N. R is the annual interest rate. N is the number of times you compound each year. It's that raised to the N times T. So the number of compoundings per year times the number of years, that number is the total number of compoundings. Now let's put in some numbers that we know. I'm going to skip the A for a minute. I'll come back to it. This is equal to, now the amount we're investing is 2,000. So we're going to have 2,000 quantity 1 plus R. Now this is at 12%, so 0.12 divided by 6 times a year, okay, to the N, which is 6 times T. Now that's what we're trying to find. Find this. Now there's something else I need here. I need A. Well, what is A? Well, what we're trying to do is find the amount of time it takes for our amount to double. All right, so to double, what we're going to have is 2,000. You double that, what you get is 2 times 2,000, or just write the 4,000 if you like, but I'll write 2 times 2,000. Now, this is going to give us that 4,000 is equal to 2,000 times the quantity 1 plus, I'm just going to write it 0.12 over 6. I'm not going to do any of these computations. I'll have my calculator do it all for me. Raised to the 6t. Now, let's divide. Let's try to isolate this exponential part here. So I'm going to have 4,000. I'll do every step here. Divided by 2,000 is 1 plus 0.12 over 6, all to the 6t. Now, I'm not going to do any calculations until the end. I'll have my calculator do it all. So, I mean, I could do this. 4,000 divided by 2,000 is 2. But if it were different numbers, maybe I couldn't do that. So, just wait till the end. Have your calculator do it all. So, exponential. Undo the exponential by taking the log of both sides. So, I'm going to get this. Now I'm going to take log base 10. Either one you want, log base 10, log base e, it doesn't matter. So, I'll say log base 10 of 4,000 divided by 2,000. This is equal to, now, over here, I'm going to take the log of this. Now look, I've got an exponential. If I put the log out here, I know what's going to happen. This 6t, the exponent, is going to come down in front as a multiplier. So instead of writing that step, you know what's going to happen. That's why you do it. So bring the 6t down already. So just skip that step. 6t times the log of 1 plus 0.12 over 6. Now, I'm trying to solve for t, right? Here's t. That's what I'm trying to solve for. I'm trying to solve for t. So look what's happening. T is being multiplied by this 6 and the log. So why don't we divide both sides by 6 times the log? Doing so, we will have, okay, here's t. I'll get a little bit of room here. This is going to be the log base 10 of 4,000 divided by 2,000. Over 6 times the log, I'll put the base in here, the log of 1 plus 0.12 over 6. We just got to figure out how to get that into the calculator. So here's what I think you should do. In the top, you've got the log of a quotient, so just press the log key. So you're going to press log, the log key, and when you do that, you get log, parentheses, put in 4,000 divided by 2,000, close it, divided by, now, here's where I want to be careful. I've got 6 times this, so I need to capture all of this. So capture all of it by writing parentheses. So parentheses, 6, press the log key, you get parentheses, put in 1 plus 0.12 divided by 6, close. Now that closes that one. then you need another parentheses to close that one. All right, that should do it. Now, what I did is I got out of this, I got t is equal to about 5 point, maybe, I got, 833, how about 834 years? Okay, I mean, about 5.8 years is what it's going to take. So how long is it going to take to double? Probably about 5.8 years, almost 6 years to double. Now, the second part says this: how long will it take if interest is compounded continuously? So write the compound interest formula for continuous compounding. That goes like this: A is equal to P, E to the R, T. Right? Pretty straightforward formula. So we're going to have 4,000 equals 2,000, right? We want to double it. E to the 0.12 T. Now, let's divide. So we'll get 4,000 divided by 2,000. That's equal to E to the 0.12 T. Now, what are you going to do here? Got an exponential, but the base is E, so we're going to take logarithms. And because the base is E, I'm going to take the natural logarithm. Take ln. So I'll get the ln of 4,000 divided by 2,000. That is equal to, now you know, when you take the ln of this side here, that's the log base E of E. The bases match, so you just get the exponent. That's why you do it. 0.12 T. Now divide. So T is equal to ln 4,000 divided by 2,000 all over 0.12. So I'm going to type in, press the log key, you get parentheses, put in 4,000 divided by 2,000, okay, and then divide by 0.12. You know what, let me make this just a little bit clearer. I'm not putting in log because I'm using natural log. So T, okay, so here's what I'm going to put in. I'm going to put in, press the ln key, get parentheses, put in 4,000 divided by 2,000, close, divided by 0.12. And I am getting that T is equal to about 5.776 years. All right, so a little bit less, right? If you're compounding 6 times a year, it takes about 5.8 years. If you're compounding continuously, a little bit less, but not much. Now, question 9 is similar to question 8, but instead of putting in $2,000, we're just going to keep it general. We're going to put in P number of dollars. All right, so how long does it take P dollars? We don't know what P is, but just some number of dollars. How long does it take P dollars to double if you put it in at 6% and you compound 2 times a year? So let's start by writing our compound interest formula. How about A, the amount that you accumulate, is equal to P, the principal, the amount you invest, times the quantity 1 plus R over N, raised to the NT. Now here's what we know. The amount that we're putting in is P, parentheses, 1 plus, we're doing it to 6%, 0.06, and 2 times a year, raised to the 2T, and that's what we're trying to find, right? Find this. Now, what about A? Well, A is the amount that we want this to double, all right? So if you put in, like in the last problem, we put in $2,000, so we doubled it to 4,000, right? 2 times 2,000. Well, now we're putting in P dollars, so how do you double P? Well, if you double something, you multiply it by 2. So I get 2P. That's the trick to this problem right here. Now, divide both sides by P. So if I divide both sides by P, they essentially cancel. So I get 2 is equal to 1 plus 0.06 over 2 to the 2T. So an interesting thing here is that the amount of time it takes an investment to double does not depend on the amount of the investment. You see that P, the principal, it disappears. This is independent of how much you put in. All right, so let's take logs. I got an exponential, I'm going to take logs, so I think I'll just take common log here. So how about log of 2? Log of 2 is equal to, now I'm taking logs, so I know what happens. Take the log of this side, I'm going to bring the exponent down in front, so I'll get 2t times the log of 1 plus 0.06 over 2. I can get t by just dividing by 2 times that log. So t is going to equal, all right, we got a log of 2 on the top and 2 times the log of quantity 1 plus 0.06 over 2 on the right. So just be careful how you put it in now. I'm going to put it in as I'll press the log key and I get parentheses. I'll put in a 2 and close, divided by, now, parentheses. Remember, you want all of this. It's a multiplication, so I need all of it. Capture all of it with the parentheses. 2, press the log key, parentheses, 1 plus 0.06 divided by 2, close. Now that closes that one, and then I need another one to close that one. All right, so I got this. I got t equals about 11.7, close enough. All right, about 11.72 years. All right, so if you put any amount of money, doesn't matter how much it is, and some account at 6% and they compound semi-annually, right, twice a year, it'll take you about almost 12 years to double that money. Question 10 asks us how long it will take $1,000 to be worth $2,000 at 6% compounded continuously. Let's just write the continuous compounding formula. A, the amount that you accumulate, is equal to the amount that you invest times E to the RT. This is A is the amount that you accumulate, P is the amount you invest, R is the interest rate, annual interest rate, and T is the amount of time. And we're asked for how long. So what we want to do is we want to find this. It's in the exponent. So we have an exponential equation. So let's use logarithms, but let's put the numbers in that we know first. So I want $1,000 to be worth $2,000. So how about the amount we want is 2,000. That's going to be 1,000 e to the 0.06 t. Now, I'm going to divide here, right? I'm going to divide. So I'll get 2,000 divided by 1,000, which we all know is 2, but I'm going to leave it like that. That's equal to e to the 0.06 t. Now, exponential, take logs, and the base is e. I'm going to use a natural log, so I'll get the natural log of 2,000 divided by 1,000. Now, when I take the natural log of this side, what does it do? You know what it does. You just get the exponent, right? The ln, think of ln here, log base e. The bases match, you just get the exponent. So I'm going to get 0.06 t. So now I'm just going to divide. So t is equal to ln of 2,000 divided by 1,000 all over 0.06. So let's put it in like this. ln, you get parentheses. So right, so second, no, so just press the ln key, you get parentheses. Put in 2,000, divide 1,000, close, divide by 0.06. And I got t is about equal to 11.55 years. All right, so how long? About 11.55 years. And those are the answers to our questions 8, 9, and 10 on homework set 39.